Hey Algebra 2 students, this is lesson 12a, and this is the first half of this lesson. In this, we're going to cover two things. First, we're going to review how we factored and how we solved quadratic equations so far in this unit, and then we're also going to cover our objective for today is be able to find zeros or solutions of our quadratic equations, so equations that look like ax squared plus bx plus c by completing the square or by using the quadratic formula. Mostly we're going to focus on using the quadratic formula. That will work all the time. It's one method that works. We don't have quite enough time to go through completing the square. I've actually included a summary of it on the back of your note sheet, but for today we're going to focus on using quadratic formula that will give us the same answers. Okay. So when you're watching these videos, your job is going to be to take some notes on the notes handout and then whatever work we're doing in our binders. And then once you've watched the videos and taken the notes, taking this, showing your classroom teacher, and then taking the exit ticket to show that you've mastered it. So let's jump right in with our do now. This is sort of review. It says find the solutions of the equation below by factoring. So it gives us a hint. We're trying to do this by factoring. And what we covered last week in lesson 11 was how we can split these quadratics up into linear terms, so like individual terms that just have x's. And one method we've talked about is for factoring quadratics so far is the box or the diamond box method. So we'll use that today as a review. So let's try that over here. The top is the product of our c and our ax squared term, so it's going to be 3 times the first term, which is x squared. And then the bottom is just our middle term, negative 4x. And in the box, we'd be putting, the middle term, an x squared, the last term of 3, and then those two middle pieces are going to be what we fill in to the middle pieces in our box. All right, so the diamond says we need things that multiply to make 3x squared, things that multiply to make 3x squared, and things that add to negative 4x. So I'm first just going to list some factors of 3, and then their sum. Factors of 3 are just 3 and 1. The sum of that would be 4. So that's not quite what we wanted. 3 times 1 does give us positive 3, but it adds to positive 4. We want it to add to negative 4. So I have to change this. I'm going to make it negative 3 and negative 1. Negative and negative does multiply to make a positive 3, and it would add then to a negative 4. Check. All right. So we've actually picked out with that our middle terms. Our middle terms are going to be negative 3x and negative 1x. So now I'll fill those in my box, negative 3x, negative 1x. And then this box just helps us pick out the factors, so the actual factors that we'd be multiplying here on the top and over here on the side to get the quadratic we have. I like to fill in x and x first because x times x will give us x squared. Then looking at this orange box in the top right, it's saying x times what would give us negative 1x. Oh, that's just going to be a negative 1. And then on the bottom, we have negative 1 times what would give us positive 3, one negative, and a negative 3. So that gives us actually our two factors. And we'll fill those in right over here. So this is going to be x minus 1 and x minus 3. So that's an example of how we could use the diamond box method to factor a quadratic. And then that really helps us find solutions because all of these factors multiplied together make 0, which means any one of them could be 0. So now that we have a factor that's easy, we can be like x minus 1 equals 0 and solve that simple equation, x equals 1. So that would be one solution. I said find the solutions. That's one of our solutions that we found by first factoring and then using our zero product property. The second one, x minus 3 equals 0. X minus 3 equals 0. Add 3, x is going to be positive 3. That's a second solution. So you could go on in and apply this same process to our other quadratic here, get its factors and find them. But for right now, I'm just going to do it out really quick. I know I have x and x, factors of 5 to add to 4. I'm going to need a positive 5 and a negative 1. And that's going to give me a solution of x equals negative 5 and x equals 1. So again, if you wanted to pause and practice that a little bit more now, you're welcome, but I want us to move on to our today's objective, which is using a quadratic formula instead of this method that we practiced before. All right, so to do this, we're going to go to our binder on page 60. And our classwork, our first example, it says find all real solutions to this equation. I see there's a quadratic in there, there's a quadratic in there, and it's equal to 0. Okay, well, this quadratic, the way we solved before, is with factoring. So let's try that really quick. I'm going to do it up here, multiplying 3x squared and negative 6x on the bottom. So factors of 3 that add to 6, the only factors of 3 are 3 and 1. And they, we saw before, those add up to 4. I could try negative 3 and negative 1. Well, they actually add up to negative 4. But that's it. Those are the only integer, the only full numbers I can think of that multiply to make 3 and add up to negative 6. I can't think of any. So we really run into trouble using our diamond box method to factor this sometimes. Some quadratics don't factor as nicely. So what we're going to use instead is our quadratic formula. All right? And I actually took the same issue is going to happen over here. This is not going to factor as nicely either. So what I did for our notes is I put on our note sheet this, what's supposed to be this quadratic, 2x squared minus 4x minus 7. I put it over here under the spot for the quadratic formula, 2x squared minus 4x, and this is a minus 7. That was just a typo. And it says factor it using the quadratic formula. All right. So here's how we use it. I'm just going to model it. This may be review for some of you, so if you're comfortable with the quadratic formula, feel free to skip ahead a little bit just to make sure you know the steps. Or if you want to pause it and try out this problem first, you're welcome to. But I'm just going to slowly step through how to use the quadratic formula to simplify, and then I'll show us some places where we can go on and practice before you come in and take your exit ticket. All right, for this first one, what I like to do first, first we need to check that it's equal to 0, right? The quadratic formula only works when we have an equation equal to 0. And that is true in this case, so step 1, we're good to go. Next, I like to rewrite the general form, ax squared plus bx plus c, right underneath. That'll really help us pick out what our coefficient a is, what our coefficient b is, and what c is. So then down here, now that we've written them together, I just need to match up my a with the number that's attached to our x squared term, which in this case is 2. So a is going to be equal to 2. Now for b, this is where I like to line it up, because when I line it up, I see that b is going to be the number that's attached to x. In this case, that's a negative 4 that's attached to x. So b is going to be a negative 4. And then c, same thing, c is going to be a negative 7. And again, that was just a typo for me transferring it. We're solving the same problem that's right here. So we have our coefficients. We got what our a value is, what our b value is, and what our c value is. Here is our quadratic formula. And this is something that we're going to be using a lot, so you should be very familiar with it, if not memorize it I know in my class I will usually provide it as a reference for people who need to use it. But all we have to do, once we have our coefficients, is really just plug them in the appropriate places in our formula. To do that really carefully, to do this plugging in really accurately, what I like to do is everywhere there's a variable where I'm going to plug something in, like this B and the A and the C and the A on the bottom, I'm just going to open up a space for me to plug that in with parentheses. So I'm saying negative whatever I'm going to put in there. I know it's going to be. I'm just going to leave a space and then go back later and I'll fill in all the numbers. So B plus or minus the square root of B, again leave a space, squared, minus 4 times an A times a C. So every time I'm saying a letter name, I'm just leaving a space with parentheses that I'm going to fill in with my values later. And then on the bottom, same thing, 2 times A. Now I'm going to color code this. You don't have to. I'm just going to color code these 3 values so that when we plug them in, we see exactly where they're going to be going. So A is going to make yellow. So any A's I see in the formula, I'm just going to highlight them in yellow. A is here, A is there. Any B's in the formula, I'm going to highlight in orange, orange, orange. And any C's in the formula, I'm going to highlight in blue. There's only the one. All right. Now we've opened it up. I'm just going to plug in our values. Negative B is negative 4. Negative 4. So the oranges I put negative 4s. A is yellow, so 2 goes in all the yellows. And C is negative 7, so negative 7 goes in our blue. So at this point, we've just really picked out what our A and B's are, plugged them into our formula. From here on out, we're pretty much simplifying. In other words, at this point, we've actually found 2 solutions, and the 2 solutions, one comes from it being a plus, the other comes from it being a minus. We found the 2 solutions to our quadratic. The rest of our work here is just going to be simplifying this very carefully. So I'm going to start on a new line. Let's say x equals negative 4 is just going to give me a positive 4, plus or minus the square root of negative 4 squared. Well, that's just negative 4 times negative 4, which is going to be a positive 16. 16. So again, that's why we want to be really careful with our parentheses. If we had not put our parentheses on this negative, we may have accidentally thought of it as negative 4 squared, which would be equal to negative 4 squared is 16. But that is not what we want to use. We want to use the parentheses so that we know it's a negative 4 times a negative 4. 16. And then this whole term, let's kind of on one go. 4 times 2 is 8 times negative 7 is going to give us a negative 56. 8 times 7 is 56. And then, so overall, we're going to be subtracting a negative 56. Again, I'm using parentheses to make sure my negatives stay separate as I simplify. And then underneath, we have a 2 times 2 or a 4. So we're really close now. Just going to finish simplifying under the square root. So I'm going to leave the 4 where it is. 4 plus or minus the square root. 16 plus 56 is 72. And on bottom, 4. All right. So at this point in our problem, we just want to now get 2 values of x that are our actual solutions. So to do that, we're going to come down here, and this actually splits into 2 possibilities, right? Either it's being added, like we said before, with the top thing, or it's being subtracted on the bottom. So the first one's going to be our solution we get if we're adding. The second one's going to be our solution if we're subtracting. So I'm going to write this out. X equals 4 plus, this is our plus solution, square root of 72. And you're welcome to write your numbers in a lot of different ways. I I think the most clear for right now will just be as a decimal. So I'm going to take this square root of 72 and just put it in a calculator and find out what the square root of 72 is. And I just did that just now, and that gave me 8.48. And actually, I'm going to take one more decimal. I'm going to do 8.485. That way we're being nice and precise, and there's not as much issues with rounding. And then on bottom, we still have our 4. I'm going to do the same thing for our minus situation. X equals 4 minus, still the square root of 72, so that's still going to be 8.485 all over 2. I can just add this up in my head. 4 and 8 is 12.485 all over 2. And then 4 minus 8, that's going to be a negative. So let me see what that would be. 4 minus 8.4 is a negative 4.485. Okay. All over 2. Still over 2. So then overall, we have 2 solutions. One where we divide. So 12.485 divided by 2 is our first solution. That's going to give us x equals 6.243, rounding up to 3 decimals. And then the second solution is going to be x equals, it's going to be a negative number, 4.485 divided by 2, negative 2.243. So those are our 2 solutions. First one, get from positive. The second one, we get from subtracting. Now, at this point, we've done our job. It said find the solutions of that formula using the quadratic formula. That's exactly what we did. We have one and another. There should be 2. We got 2. Great. If we wanted to write this back in factored form, though, remember from in our do now, when we first factored, then we found our solutions. It will be useful later on for us to see our quadratic written in a factored form, even with this decimal answer. So if we wanted to do that, this isn't necessary today, but it's just showing it to us for later on. Earlier when we had a plus, we had some factored form. We had like x plus 1 gave us the solution x equals negative 1. So what we're going to write down here is we're going to say we had some factor of x, and then it would be a minus this first solution, 0.243. That factor, if we work backwards, would give us the x equals a positive 6.243. And then in the other version, we'd have x plus 2.243. Don't worry too much about this last one. We really care that you can get these solutions in this lesson. All right. Great. So we've done one big walkthrough of this. I'd like now for you to do the following. I'd like you to go back to your binder on page 60. Down here on exercise 1, these are two quadratics right now that are set equal to 0, two quadratic factors. We can split this up using the zero product property as x squared minus 2x minus 4 equals 0. So either that's true, or this one over here, 3x squared plus 8x minus 3 is equal to 0, or that, or oops, equal to 0, or this is true. So basically here we have to find all the solutions to this bigger equation. We can find the solutions to 2 separate quadratic equations. So what I'd like you to do right now is go back to the example we walked through, and in your notes there's a summary of how to do this too. This is kind of like an overview of another example worked out. It's called Solving Quadratic Equations on the back side of your handout with quadratic formula. make sure it's equal to 0 as a first step, figure out what the values A, B, and C are, plug them in, and simplify. So using this and the notes you just took on the front side of your handout, I'd like you to try out these two quadratics, finding their solutions using the quadratic formula. So pause the video, go ahead and try these two out. When you're ready or when you want to check or when you get stuck, go ahead and restart the video and you'll kind of watch me walk through it. But I'm going to be walking through it really quickly, so it's really important that you pause it and try it out first. All right. So hopefully you've tried these out. Here is how I would approach these. I would kind of match up my ax squared plus bx plus c, my general form. I see that this is equal to 0 already, so we're good to go there. Step 1, kind of from our reference, is set. Step 2, I need to pick my coefficients. The number that's being multiplied by x squared is 1. It's like a 1. It wasn't written there explicitly, but we know there's 1x squared, so a is going to be 1. B is going to be, this one's easier, -2. And C is going to be -3, or sorry, -4. We have those into our equation. And now I know this, -b plus or minus the square root of b squared minus 4 times a times c. As we practice with it, you should get used to using it and not need to reference it, but if you do, it's on your notes. Now I'll plug in the pieces. We got a -2 there, -2 there. An a is 1, a c is -4, and it's all over 2a. Simplify this, it's going to be a 2 plus or minus, oh boy, we got 4 is this one. This is all going to multiply to -16. And so it's going to be 4 minus -16 all over 2. And then that's going to be 2 plus or minus a -4. That's going to be a plus 16. So that's going to be 20 all over 2. Square root of 20 is in a calculator. I know it's going to be more than 4 because 4 times 4 is 16. And less than 5. 5 times 5 is 25. So yes, square root of 20 is 4.472. So 2 plus or minus 4.472 all over 2. Now we want to split up our two separate solutions. One possible value of x equals, if we add it on top, so this is our add solution, and one possibility where we subtracted. So if we added, the top would become 6.472 all over 2. And if we subtracted, we would get -2.472 all over 2. And this one's going to give us an x. And I'm going to use the approximate squiggles. Again, we did approximate our square root to 3 decimal places. So I'll just keep our approximate there for right now. 6.472 divided by 2 is 3.236. 3.236. Check. And the second solution will be -2.472 divided by 2. X is approximately equal to -1.236. So there are two solutions. There are two of the solutions coming from this blue part of our original equation. There should be two more that come from the pink part of this original. I just highlighted in pink this other one. So we want to practice this all again. I'm going to just go through it even faster this time, now that we're so used to it. I'm not going to write out explicitly what a, b, and c are. I'm just going to be -b plus or minus the square root of b squared is going to be 8 squared minus 4 times a times c, 4 times 3 times -3 all over 2 times a. 2a is 6. All right, and then simplify -8 plus or minus, it's going to be 64 minus a -4 times 3 times -3 is 36. So it's going to be 64 minus a negative 36, which is actually plus 36. All over 6, negative 8 plus or minus square root, that's going to be 100, so that's just going to be 10 all over 6. So I'm going to get, so x is either, if I add them, if I add those terms on top, it's going to give me 2 over 6. If I subtract them, it'll give me 8 minus 10, that's negative 18 over 6. And so x is either going to be equal to 1/3 or approximately equal to 0.33, repeating, or x is going to be equal to 18 divided by 3 is negative 3. And I think, let me check. Yes, that was the same example we did in the walkthrough over here. But there's me annotating through it. So that's pretty much what we need to know how to do today. Again, to summarize, it's really just once we make sure our things equal to 0, pick out what our coefficients are, plug them in, and then simplify. If you need to do more practice, there are 2 more here to try out. But once you're ready, stop by and take your exit ticket to show your mastery for this lesson.